You guys having a good conference? Yeah? Good. All right, so here's what we're going to be talking about today. I'm going to let you read the bullets, but the highlight is that we're going to be talking about big data and Hadoop, and why I personally believe that probably every person in this room has a need for Hadoop. Maybe not today, but they will in the near future. So if this does not look like the kind of content you're expecting, please, you're welcome to leave. I promise you won't hurt my feelings. But this is what we're going to be talking about. So I'm going to start briefly with a little bit about me. I don't normally talk on these slides. I usually kind of skip right over them. But I've done a lot at GoDaddy over the last 8 years, but I've not done analytics directly. I've never been an analyst. I've always been in a role that was supporting analyst or analytics. I started off as a DBA for what was and still is our largest SQL Server database. Many terabytes, billions of rows, thousands of transactions per second. And there were some interesting challenges there. But what was more interesting was the data that we were capturing had a lot of value. And that started me thinking, how can we use data to add value? How can we create a better experience? How can we increase revenue? So everything that I've worked on since then have always been in these data consumer roles. I have built backends for data viz. I have done data warehousing. I've automated ETL. I've worked on personalization projects for our, at the time, statisticians, but now I think they're called data scientists. We're building logistic regression models and neural nets, and I was operationalizing those and feeding them out to applications so that we could change what we were doing real time. And I've seen that there's just been a lot of value in the ability to have data accessible to various parts of the business. Now, at the moment, I am leading the platform data management team. And we're agile, so I have 2 roles. I'm a functional manager for a team of data engineers, and I'm also the product owner for data management. And when I talk data platform at GoDaddy, what that means is any system that's used either directly for analytics or for serving systems that are focused on analytics. So that is SQL Server, MySQL, Teradata, Cassandra, and then at the heart of this platform is Hadoop. We do have a data lake. All of our data in our company is sitting in Hadoop. And as far as my responsibilities or my area of focus, I think in many ways we have become data rich but information poor. We have 88,000 objects registered in each catalog. We have many more that are unstructured, that are not registered there yet. And it becomes very difficult for our analysts or for other people that want to consume this data to understand what is the high value data, what is the definitive source of customers, and what are the high value customer data sets that we have. Because if you search for something like customer, you're going to find it everywhere, right? Everybody cares about things like customer and order, but what are the true sources of that data? So my focus is really on making data easy to consume. One of the things that we're doing is, or what we have ownership over, is enterprise data processing. So this includes data warehousing that we are doing in Hadoop, and also any processing of high-value data sets. The other part of that, which goes hand in hand, is data processing architectures, methodologies, frameworks, and templates, because my relatively small team of data engineers cannot possibly parse and process the petabytes and the tens of thousands of tables that we have, right? It's not feasible. We would be a bottleneck. So we want to enable self-service for any team that wants to use the platform. So the reason why I tell you this is because even though I can talk to our hardware and our infrastructure and our serving platform, what I'm really focused on is what's happening inside of Hadoop. So if you have questions around that, I'm going to be the most knowledgeable and can answer those types of questions the best. So that's a little bit about me. Now I want to know about you guys. I want to know what your roles are. How many of you are primarily data analysts? Okay. How many of you are primarily BI developers or data warehouse developers? Okay. DBAs? Okay. Data scientist or aspiring data scientist? Okay. Okay. Managers, leadership? Anybody I missed? Didn't fall into a category? Okay. How many of you are currently running Hadoop in your production environment today? 2. How many of you are directly using, of you 2, how many of you are actually using Hadoop directly? No, okay. How many of you are still trying to figure out if you even really need to use Hadoop or be aware of it? Okay, thanks. So we're gonna shift focus. I'm not gonna talk about Hadoop right away. I'm gonna talk about data. EMC has sponsored a study for the past 7 years called the Digital Universe. And it's prepared by IDC, and it is the only study in the world that I know of that attempts to quantify and forecast the amount of data we create annually. So this is not the amount of data in the world, it's just the amount of data that we created that year. So of course, being a good nerd, I went back and I read 7 years of these reports and found some really cool things, and I created you guys this beautiful chart. And that's the extent of my data viz skills, just so you know. So you can see though, that what's interesting is over the 7 years that they created this, or that they prepared this report, we have grown 22x in the amount of data that we are creating each year. We created 4 zettabytes in 2014, and they are forecasting that we will create 35 zettabytes by 2020. Now guys, it took me a minute to realize that's only 5 years away. 35 zettabytes, 35 trillion terabytes will be created in 5 years. It's huge. And I can tell you one thing is that when I looked at the data that was prepared by EMC, they were always conservative in their estimates. When you look at the data that we're creating and the types of it, 80% of it is unstructured. So this means 80% of the data that we create each year is not sitting in a relational database. It's semi-structured or unstructured. What is driving this, guys? What? Sensors, Internet of Things, mobile. So there's really 2 things that I see that are driving this. One, it is the incredible technological advances we've had over the past decade, right? We've had some really cool things happen, and we're gonna continue to see a lot of growth in things like sensors and the Internet of Things. It's not really what's driving that today, though. What's driving it today, what's driven this 4 zettabytes, is us. But I'm not talking about the Web 2.0 movement, which is what everybody seems to think. They think it's all Twitter and Facebook, and that's a part, but it's really our pervasive use of technology in every aspect of our daily lives. So, I'm gonna walk you through a typical Saturday morning at the Ufford household, and I have young children, so it's not uncommon for my husband and I to make some tentative plans during the week, but it's not until Saturday morning that we make a go, no-go decision, which basically sounds like we wake up, hey, are the kids well? Yep, let's go. So we haven't done much in the way of planning until that morning because we never know. So I'll usually wake up, we'll decide we're gonna go, I'll go to Facebook because of course everybody wants to know what we're up to that day. I'll say we're gonna go to the zoo or the amusement park or the aquarium. And I might also text my sister or maybe some family friends and see if they wanna join us. Then I'm gonna pull up my weather app and I'm gonna see what the forecast is for that day because I want to know how to dress my children. I'm going to pull up my tablet or my laptop. I'm gonna do a search for the place we're going to. I'm gonna go to their website. I'm gonna click around until I find where to buy the tickets. I'm gonna enter my PayPal information. I'm gonna buy the tickets. Then I'm gonna get the children in the car and I am going to pull up the directions to that on my GPS. As we get in the car, my sensors are showing that we need gas. So we're gonna go drive to the gas station. We might also have to get some air in our tires. We're gonna make our payments. And then we're gonna get on the road. And we might have a short drive. So my daughter, she's just learning her ABCs. And so the Kindle has some really cool apps where you can trace the letters and do face or flashcards. So I'll probably hand her the tablet back to occupy her while we're traveling. So we'll do that, and then we'll actually get close to our destination, and we'll hit the city limits, and we'll find that my husband was probably going a touch too fast, went over some sensors, and in 7 to 14 days, we're probably gonna get a speeding ticket in the mail. Lucky for him, I don't know right then, but then I'm gonna get to my destination, and like any good social media user, I'm gonna check in because my family and friends were waiting to see when we made it. And then I'm gonna get the kids out of the car, we're gonna go up to the admission gate, and I'm gonna show them my tickets. And they're gonna have a nice little sign that says, hey, you should download our app because we've got a map and we've got really informative information. And I think, that's cool, so I'm gonna do that. We use that as we walk around. And like any adoring parent, I am taking lots of pictures and videos of my kids because they're so cute. And I'm not alone in that because the zoo is also taking pictures and videos of us, not because we're cute, but because they want to make sure we're not doing something we shouldn't. And then finally, we might stop for a snack, and I take the few best pictures and I post them to Instagram. This is the first 3 or 4 hours of my day. And I have created this digital trail that I am mostly unaware of. In fact, when you look at the data that I directly created, it's a handful of social media posts and pictures and videos. And when you look at the types of data that I created, again, mostly without me being directly aware, only a couple of these are probably structured data. The point of sale is probably structured, right? Everything else may have a structured component, but it is primarily unstructured or semi-structured. This, guys, this is where the data is coming from. This is why resistance is futile. Because this isn't going away, it's only gonna get bigger, right? The Internet of Things is upon us. My husband, for our anniversary, bought me a washer and dryer, which normally would be a bad thing. But he sprung for the smart washer and dryer. So I got super excited. I mean, I can take my cell phone over there, I can see the stats and see how many times, how many loads did he wash? And I can also download new cycles so I can get more efficient drying. And I can also connect it to the power grid and say, I'm gonna load it. Well, I never actually do this, but if I wanted to, if I had enough forethinking, I would load it, and then I would say, don't turn it on until it's at the optimal time for power consumption. The Internet of Things is going to be here, and this is only going to increase the amount of data. And that's why we're expected to get to 35 zettabytes in 5 years. Questions on this? Does it make sense? Does this look like anybody else's life, or is it just us? Okay. See some nodding heads. Yes?
Isn't some of that data structured like in pictures and so forth? They do have dates and maybe locations attached to them. Do you consider that structured, or
it's actually
kind of thing?
It's actually not really structured data. It has attributes, right? And I think unstructured data or semi-structured data is a misnomer because we consider semi-structured data to be like JSON or XML, and it has a format, right? It has a format and I can read it. But the difference is that when I'm going through a system, I'm not having to verify the schema necessarily, right? I'm not gonna reject it if it doesn't match that schema. So same thing with your files, like your images, it's not gonna fit into a database, so it's not gonna be a structured file, even though it might have information that you could parse and put into a structured table. But no, I would consider those images to be unstructured, actually. Good question. All right, 3 V's of big data. So how many of you have heard of these 3 V's? A few of you. Okay, there's 3 V's that we hear about. The first is volume. Data at rest. How much data do you have? How many of you guys actually have like 100 terabytes of structured data? That's really awesome. Actually, I see about half a dozen or so hands raised. How many of you have like a petabyte or more of unstructured data? Couple hands. How many of you have thousands of transactions per second or real-time or near real-time latency requirements? Okay, some of you guys. You guys have big data, no questions about it. I have big data, we have these challenges. How many of you guys have a variety of data, including relational data from SQL Server, MySQL, or Oracle, semi-structured data such as JSON or XML, social media data that you're downloading from Twitter or Facebook or Instagram, or maybe you're actually getting product reviews from Amazon, multimedia such as those images or audio files or video files, geospatial data, telemetry data or sensor data, clickstream data, email, either internal to your company or external. Maybe it's customers that are emailing you for support. Documents, including Word documents, Excel, PDF, text files. How many of you have more than one of those in your company? Every single one of us has that. Now, every single one of us has big data. In fact, I think big data is a misnomer. I should really just call it difficult data, right? We all have data that's difficult to work with. And you don't really have a big data challenge unless you've got volume, velocity, or you're trying to do analytics or integration with a variety of data. And it is this last one that applies to everybody. Now today, you might not care about your unstructured or semi-structured data. You might not even know that it's there in your company. Or you might, but you might not fully understand it. Going back 3 years ago at GoDaddy, I knew we had 100 plus terabytes of structured data. I could tell you what the data was and where it was sitting. And from my perspective, that was the super valuable data in the company. And we also had some hosting logs and security logs and other stuff that we knew about. Guys, 90 to 95% of the data in the company is unstructured or semi-structured. And I had no clue because I was a DBA and I was focused on structured data. And there is a lot of value in this information. It might take some massaging or parsing to get to it, but there's a lot of value in that. And this is the kinds of reasons why you guys are going to see that you need Hadoop when you want to use that data and do things with it. Does that make sense? And by the way, guys, I didn't say anything, but please feel free to stop and ask questions as we go. All right, data co-location. So I personally get really excited about data co-location. I really think this is what everything's about. I think this is what's really driving the excitement about Hadoop, because ultimately it's not about technology. It's about the fact that we finally are able to co-locate all the data in a company. I have semi-structured sitting next to unstructured sitting next to structured data in my data lake. And what that enables is us to ask more interesting questions. So we have two different things here. At the bottom, I've got the data set. It's a hypothetical data set. At the top of that triangle is the value to the business. This is the types of questions you have. On the left-hand side, I also have phases of business analytics, right, and the types of phases that we're enabling. So as I co-locate more data, I'm going to move up that arrow on the left. So we start with just one data set. And I can be very descriptive with this data set. I can ask what happened types of questions or what's currently going on, such as how many customers do we have? How many customers did we acquire last month? What is our acquisition rate year over year? How are we trending? How many of you guys are focused on asking these types of questions or answering these types of questions? Right? It's the vast majority of what we do, I think, in BI and analytics is just kind of telling people, here's what's going on, here's what just happened or is presently happening. So it's very descriptive. But then we co-locate another data set, and we could choose to become more diagnostic, or we could choose to be more complex with our descriptive questions. We can answer more interesting things, such as why is something happening? Why are support calls increasing? Why are email rates lower or email response rates lower than we expected? How many of you are focused on answering why questions? I see a lot of ad hoc analysis is done on the diagnostic. Something that I'm reporting in my dashboard on my descriptive analytics does not make sense to me. Go tell me why. Then we've got more data co-location. Now this time maybe it's semi-structured data that I'm co-locating. And I can choose to answer even more complex questions, or I could move upward and say I'm going to answer predictive types of questions. What will likely happen? This is where we start to see the beginnings of data science. Which orders are likely fraudulent? Which customer cohorts are likely to attrite? Which customers would be most interested in upgrading to a premium plan? Very, very useful information, but not nearly as useful as prescriptive analytics, where we actually try to influence the behavior based on these other analytics we have. So I can now move to to enabling things such as which content should be displayed on front of sites to increase the likelihood that this customer will convert. Or which channel is the optimal channel for communicating this marketing message to this customer? Which actions should I take that will most likely result in saving this high-value customer from a trading? How many of you are doing this? This is very hard to do. And I'll tell you why, guys. When I've worked on predictive projects and prescriptive projects, we're doing a lot of this today. 75 to 80% of our time was spent on the data collocation, just simply spent on the ETL. And when our analysts and when our data modelers were trying to do theirs to see, like, as a proof of concept, to see if it was even worth productionalizing, they were spending 80 to 90% of their time doing the data collocation. So the more that we have this data collocated, the faster we can get to those different places. Because when you're trying to do predictive models, you need a lot of inputs. I mean, hundreds of attributes to input into these models. And the more attributes you have, the better they're going to be. Does this make sense? So you can choose to move up the level of maturity of your analytics, but you're never going to get away from descriptive analytics or diagnostic analytics. The business always wants to know how it's performing and why are things happening. The difference is that you can now answer more complex questions. How does each phase of a product usage lifecycle affect customer lifetime value? Is that something that you guys would be interested in knowing? We're interested in knowing. Now, product usage data is not structured. It is ugly, ugly data to get that out, right? But there's so much value in that. And that's not something that we necessarily need to put into a predictive or prescriptive model. It's just something we need to know the answer so we can understand behaviors. Or why did the latest release increase customer support request? What access patterns did they have in common for customers that called in? Again, not something that I would ever want to put into a predictive or prescriptive model, but extremely useful information. I can understand why our customers are having troubles, and I can fix it. But you can't answer these questions easily. It's not that you can't answer them, right? Because you guys can always do one-off ETLs. You can always find the data and move it, and maybe it's on your desktop, maybe it's on a server, but you guys can always pull that data together. It's just going to take a lot of time. Does this make sense, guys? Yeah. Okay, so we talk about Hadoop and we talk about MPP systems, but I don't think that people really understand what MPP means. So I'm just going to take a brief moment to explain the difference between SMP and MPP. SMP stands for shared. Just think shared. Everything along, it's a single server, it's got shared CPU, shared memory, shared disk. Give me an example of an SMP system. Oracle, SQL Server, MySQL. Any database system that you work with pretty much is symmetric. Does anybody know what MPP stands for? Massively parallel processing. That's right. So instead of having a single server, you have multiple servers working in conjunction. Now, I've generalized this to be able to explain how all MPP systems work, whether it's Microsoft APS PDW, Netezza, Vertica, Teradata, Hadoop. They all work generally the same way. The terminology might be slightly different, but they all have many data nodes or servers working together. And your data is partitioned physically across each one of these data nodes. When you go to query the data, you have a single logical name. You don't need to know where the data resides. The system knows it for you. And now, if I had to scan all the data in this table and it's got 1 billion rows, I had to wait for all 1 billion of those rows to come back from that single server. It's very slow. In a massively parallel processing system, I only have to wait for 10 million rows to be scanned. It's way faster. They all do it in parallel, and I just have to wait for the slowest node to get back, and then I get my answer. But what's even more useful is the fact that this is directly, linearly scalable. So if I go from 100 nodes to 1,000 nodes, instead of having 10 million rows and 10 gig, I now have 1 million rows and 1 gig that I have to scan. So it enables very fast processing of, or very fast analytical processing, right? Scan-intensive workloads. So let me tell you, we had that database I talked about, the largest one. We had some issues with analysts trying to query it. Their queries would come back and it would be 4 or 6 or 8 hours, or sometimes they would never come back because they were trying to join billions of rows to billions of rows and it was not indexed. So it was trying to do all these multiple scans and joins. And I worked with them, with the analysts, to understand optimization techniques, so they understood how to look at query execution plans and how they could understand if there's a bookmark lookup, you want to avoid that, and how to make suggestions for index improvements. And they got very good at it because when they did that, their queries went from 4 hours to 10 minutes. In an MPP system, without any optimization at all, the same query against that same table came back in less than 1 minute. So from an analyst perspective, if you're working with large data, you're going to get better performance. And the thing from an analyst perspective is that you're not always asking the same questions, right? So it's very difficult to optimize for you guys because you want to see it one way today and the next day you want to see it a different way because there's a different business question. So they work very well. But that's what MPP is, and that's what the basic difference is between Hadoop and SQL Server. Okay? It depends on the system. No, so the question was, is it overly complicated to answer? How does it know where to look? It depends on the system, but usually there's some sort of hashing algorithm. PDW has a node, a head node that basically does that for you. On systems like Teradata and Hadoop, it does it like as the query comes in, each data node does a hashing to see where the data would reside based on some sort of key. Go ahead. Do you get lots of fragmentation? It's a good question. I would imagine so, but I really haven't looked at fragmentation in those systems. Does anybody know? Do you get fragmentation? Is anybody using an MPP other than Denise with like Teradata's? Oh, okay. I haven't seen it yet. I don't know. I'm gonna follow up on that. I want to know now. Does Hadoop have fragmentation? Does anybody know? Okay. Good question. Any other questions on that? Okay. So finally, we're going to get to Hadoop. This is Hadoop. Now, I took the Hortonworks distribution. When we talk about Hadoop and we talk about distributions, what it is a prepackaged version of all the different components that make up the Hadoop ecosystem. So these are primarily open source Apache projects, and Hortonworks has chosen these to serve these particular needs. Cloudera also has theirs, and they might have chosen different solutions for each of those components. And then you also have HD Insight. They might have different ones. There's also MapR and a lot of other distributions. This slide is actually, I like it because I'm a very a very visual person, and I want to see all the different components and how they all fit together. But I also hate this diagram. I hope nobody from Hortonworks is in here. I hate this because when somebody is learning Hadoop and they look at this diagram, they go, oh my God, there is so much to learn. I need to know Embari, and I need to know Storm and Hive and Scoop and Kafka. No, guys, no. The Hadoop ecosystem is made up of all of these different components, but the only components you need to focus on is what you need to do your job. If you're doing analytics, you're primarily going to be using Hive. Hive is a SQL-like language that creates basically the MapReduce jobs that it's going to run for you, but you don't need to know about that. You just need to know that you're going to run SQL-like queries and get data back. If you're trying to do ETL or data processing in Hadoop, you could use Hive or you could use Pig. We use Pig because it has a little bit more robustness to it, and it's also better suited for working with unstructured and semi-structured data, which is, again, what we're really interested in. So learn the technologies that you're interested in. The 4 that I think are most common, I put down here at the bottom. HDFS, Hadoop Distributed File System. This is the core component of Hadoop. This is what I just showed you on the prior slide, which is where we take the data and we distribute it across all those nodes, right? So distributed data, Hadoop Distributed File System. Hive, as I mentioned, is a SQL-like language for querying HDFS. Pig is a data flow language or data pipeline language that's very useful for ETL or advanced analytics. If you're doing data science, you might want to do it in Pig. Hcatalog is something that you guys typically won't have to interact with directly because it is part of Hive now, and it's the metadata for understanding how to retrieve data from HDFS. However, Hcatalog can be very useful if you're trying to interrogate metadata to find out where data resides, like which tables contain a column with this name, or which tables do I have that are empty. You can ask those kinds of questions of Hcatalog. But if I were you, I would focus primarily on the 2 technologies on the left, HDFS and Hive. It's the easiest place to get started. So we're going to assume that you guys have a big data need. So you have your production systems running, and you have your existing analytics and your existing data viz, but now you have a need to integrate unstructured or semi-structured data with your structured data. How do you do it? The good news is that you get to keep pretty much everything that you have in terms of analytics and data viz. You're going to start off with data. I am guessing that everybody in this room is working with data in some capacity. Primarily, though, it's going to be this relational database management system. You might not yet be looking at these other types of data, even though they exist in your company. Increasingly, we're also seeing third-party data be something that we're interested in. You could get third-party data through strategic partnerships, business to business. You might be subscribing to other data sets, such as Dun & Bradstreet through Microsoft Azure Marketplace. Or you might be interested in public data, like the Twitter feeds, or Wikipedia dumps, or weather patterns. So there's a lot of really great information out there. And maybe it's actually the third-party data that you're trying to integrate with your corporate data, because a lot of that data that's coming in is not coming in a structured format. So how do you do it? Well, you need Hadoop. I have Hadoop here, but this is a placeholder. This could be in the cloud. It could be a VM that you run on your desktop, right? The point is that you have a need for this technology. I would actually recommend that you guys use a distribution, or maybe even use the cloud if you're starting with this and trying to do a proof of concept, right? So you have a Hadoop instance somewhere, though, sitting there, ready for you to use. You guys don't have to worry about installing or setting up Hadoop. We need to get the data in there. Now, I would argue that if you have a production Hadoop cluster, that your data team, I don't know what you would call them, but your DBAs are responsible for getting the data into Hadoop, right? That is not the role of an analyst to do ETL. In fact, you want to have an analyst doing as little ETL as possible so that we can take advantage of your true skill set, which is analysis, right? We don't want you doing ETL, but you might have to do ETL if you don't have those services. So how do you do it? You could use Scoop. You could upload the file using Hue, which is a web-based visualizer, but you get the data into Hadoop. Now what? You use Hive. You write a SQL-like query, you do the transformations that you need to get it into a structured format, and then you get it out of Hadoop. You don't serve data from Hadoop. You don't do data viz in Hadoop. You don't interact with the data in Hadoop. You only use it for processing. Any other uses of it, you're probably going to be very disappointed. So you have a couple different ways of doing this. You can ship this over to your desktop directly, and you could connect your desktop to one of your data viz tools. You could access this data using Excel or maybe Power BI. You could even use some of your tools like Tableau, we use Tableau, so I'm pretty well familiar with that, but we have Tableau data extracts that connect to Hadoop using ODBC connections through Hive. And the process itself is kind of slow, but it reads the data back into memory. And then in Tableau, you don't care where this data came from. You just have it available for you to use with your data viz. You can also ship the data elsewhere. This is what I think happens the vast majority of times. So I say serving platforms. This could be an existing SQL Server data mart that you guys have. It could be Cassandra. It could be anything. But basically, you ship the data that you process in Hadoop somewhere else to serve either to applications or for analysts or for data viz. And that's going to give you the best experience. And that's what really I think the common scenario is for Hadoop, is this data processing. Yes? So, good question. What are you doing with the unstructured data to make it structured in Hive? I'm going to show you a brief example in a couple slides, but basically, Hive allows you to read unstructured or semi-structured data in as though it were structured, and then you can materialize it in a structured format or in like a comma-separated file, some file format that is easy for importing into another system. Oftentimes, you'll have data that is 90% of the way ready to be imported, but you run into difficulties. You can cleanse that data here and remove those issues, and then it's easier to import into your existing systems. The other things would be integration, right? So if I've got unstructured data and I not only want to structure it, but I also want to integrate it with another data set, that I would do it here. All right, so there's 2 times in my life that I've seen analysts get genuinely excited about Hadoop. I mean, like giddy excited. And this first one was actually, I was telling this a little bit before our session began. It was an analyst, and this was before we had platform-based analytics and before we had this giant data lake. I had an analyst who was trying to import a file into Teradata, and he was running into so many issues. He tried for a day to get it into Teradata, could not do it. Tried for a day to get it into SQL Server, could not do it. This file, though, was like digital gold. It had some really useful information, so he had to do it. Finally, he remembered that he had gone through this Hortonworks training. He had a VM installed on his local machine. So he fired up the VM. He imported the file. He wrote very simple queries. And 30 minutes later, he had the data in Teradata. And he was excited. He was excited because finally he had a place to clean up all this data that he was trying to import. Do you guys run into data import issues? Anybody? Yeah. Are you guys, how many of you are actually like have a enterprise data warehouse of some sort? Okay. Are you guys like importing third-party data into that? It's primarily when we're trying to import third-party data that we run into problems. If it's going from one of our database systems, typically we have control. So if we run into a parsing issue, we can go back to the source system, fix it, dump it out again, and then we have no issues. But it's when we're trying to import those third-party files that we run into a lot of issues. So in his case, in his scenario, he had and this is a very simple example, guys, but in his file, he had the more attribute-y type data on the left-hand side, and on the right-hand side, it just so happened that there was this unsanitized, user-inputted field. And you can imagine what that looks like. There are tons of delimitors and special characters and everything else you can imagine. And it was that last column, or that last field that was creating difficulties for him. And he did not care about that at all. He only wanted the stuff on the left-hand side. So what he did is he tried to upload it to Teradata. It failed, so he couldn't visit. Instead, he uploaded it to HDFS using Hue, which again was that web-based GUI client. And when I say upload, I mean, again, this is on his desktop. He used Hive, and he created an external table that sat over top of the file. This external table is metadata that tells me how to read the file. And in his case, he just said, I've got a flat file, it's comma delimited, and that's it. And then he was able to write a select statement, select just the columns he wanted to, which was like the first half dozen on the left-hand side. And he was able to ship it over using Scoop. And that's what he did. And it made his life so much simpler. So what we found is that, again, we're using Hadoop as a data lake, but there is a lot of need to use Hadoop as a data refinery, which is just simply the place to parse and process and deal with difficult data and ship it to where you need to consume it. So you don't need to replace any of your existing infrastructure at all. It all stays. You only use Hadoop when you have these difficulties to augment your existing capabilities. Any questions on that? Okay.
What was wrong with it? Why didn't people read it?
It had the delimiters in it, and it was user inputted, and so he kept trying to like create all these columns, but it was so difficult because he had delimiters in it. He also had like new line feeds and carriage returns, and I did not actually try to import it myself, but he was telling me about it. It sounded nasty. But with Hadoop, you load the file first and you apply the schema second. It's completely different than any other system. So this is another example, and I get really excited about this, and I think this illustrates so much of the capabilities of Hadoop. Imagine you have a JSON file. Do any of you work with JSON or XML data? Okay, key value data at all? Okay, so imagine that you've got some of that data sitting on disk. Like I said earlier, it's semi-structured, right? It has some structure to it, which means that we should be able to know how to read it. And we have an analyst who wants to query it. So what does he do? He creates an external table in Hive, which is metadata that sits on top of this file residing on HDFS. Create an external table with these attributes, these columns, which are attributes in my JSON. And I'm going to use a JSON30 format. And here's where it's stored. And now I can interact with this with a select statement. Select from. And if I wanted to join this to an existing structured table, all I would do is join to my table on this column. It's that simple. You can interact with this as though it were a structured table. But this is a very simple example, and there's 4 attributes in this. In real life, it might have 50 or 100, or maybe the payloads are different for each JSON. So there's another pattern that you can use, which is another external table. And instead of actually defining each one of those attributes, we have another analyst who came in and said, I'm going to read that entire row as a single string. And I am only going to extract the attributes that I care about. That way, as an analyst, I don't have to sit there and read through 50 or 100 attributes and assign it a data type. Because I'm just trying to get my job done, and this is an ad hoc analysis, and I want to do as little work as I can. So that's what she does, and it works. She can get the data she needs, and then maybe she ships it elsewhere. And then we've got a third person who is, maybe he's doing some data processing in Hadoop, and so he's using Pig instead. He can also read the same file using Pig with the JSON loader. This is 3 different ways for reading this file. There are many more, but the point here, there's a couple points. 1, they are all reading the same file that sits on disk. Nobody is actually doing any ETL. The analysts are not materializing this data. They are not writing ETL. They're saying, this is how I'm going to read this file so I can do my query. They no longer have to worry about ETL processing. They don't have to worry that everything was great yesterday, but something happened and now they don't have data in their data mart, because that's not the role of an analyst. They just rely on the data to be there. And if it's not their problem. It's the problem of the person who wrote the data out. So it frees up the analyst from having to do those data ETL or data engineering type roles. Does this make sense? This is so cool, guys. Like, this is really, really cool stuff. The fact that we can have 3 people independently choosing different ways to interact with this file. Think of Hadoop HDFS as your Windows Explorer, and you've got a file sitting there. And you can choose to open that file in Excel, or maybe you've got a text editor like Ultra Edit, or you've got Notepad, Or maybe you're a scripter, so you can use Python or PowerShell. It's the same way. You guys get to choose what language you want to use and how you want to use it. It's really, really cool. Okay, so and then again, these were the languages I talked about that are relevant. Yes?
Just wondering, from an ETL perspective, like a comparison, are there any instances where you need to worry about visiting, I guess, for want of a better term, kind of virtual attributes, or where they're out of bounds errors or things like that? Classic ETL problems. Do you run across any of that sort of thing with this kind of data?
Yes. Yes. Do you run into issues with the data? Absolutely. In fact, I would say many times you're going to find more issues with the data in Hadoop because there is no schema binding. So you have somebody who's writing out data to Hadoop and they think they're writing it out into a perfect JSON file, but then you find out that instead of them using colons, for some reason they decided to use equal signs. I don't know why. So we've run into that quite a bit. And the nice thing is that it's very easy to fix those in Hadoop.
So does the analyst fix that, or do you have other
we have
programmers or something who does that?
That's a good question. Does the analyst fix it? No, the analyst in our company does not fix it. We have data engineers that would be responsible for fixing that. Or, well, two things. One, we would have to fix the data that we currently have. And then secondly, we'd have to go back to the source team and tell them to fix their processes. Good question. Okay, reasons to use Hadoop for analytics. One, you work with very large data. So as we saw, there's definitely a handful of folks that work with large data. You guys might be interested in Hadoop for performance. However, if you're only working with structured data, like I said, there are better options and you might be disappointed if you're only joining structured data to structured data in Hadoop. Secondly, you want to analyze text data. You can do some really cool things very easily. So I was able to take chat transcripts that we had and tokenize it, apply a sentiment dictionary, and say by geography and by segmentation, what was the sentiment of that overall conversation? It was 15 lines of code. Guys, 15 lines. It would probably be 500 in SQL Server, if that. I mean, it was so easy because it's built for that. It has a lot of functionality and capability around that. If you're trying to work with difficult data, so if you're having some of those issues we mentioned with ETL, it's not that those issues go away, it's just an easier place to work with the data because the data gets loaded and then you can apply the schema after the fact. So if you need to process the data to fix some of those issues, you can do that before trying to apply the schema. You want to join different types of data together. So if you're trying to join any of those different types of variety of data, this is going to be where you want to do it. Because you guys are analysts, well, at least the ones who raised your hand as an analyst. If you're an analyst, you want to save as much time as you can on having to do data processing. You don't want to spend 75–80% of your time doing ETL. You want to be doing analysis. And this is going to enable an easier experience when you're dealing with difficult data. And increasingly, because that's where the data is, companies are realizing that if nothing else, Hadoop is a relatively cheap place to store your data. So if you look at your production SQL Server or Oracle systems, you'll see that you have a lot of data that nobody's accessing. A lot. In fact, there's some point in time in which you would realize that that data is mostly cold. And that's when you want to archive that data off to free up the very expensive storage that you have, to decrease the amount of maintenance that you have to do on those systems, to decrease the size of your backups, to increase your time to recovery in an event of a failure. So there's a lot of benefit to getting that data out of those production systems and moving it somewhere else. And if you can do that in a place where the data is still accessible, that's awesome. That's a great question. I don't have that answer. But if you...
Well, you wouldn't because you need the SQL Server to do the transactional system.
Well, you still do need... Yeah, you're right. You still do need SQL Server. You're talking about the historical. Yeah. It's a good question. Touch base with me afterwards. I might be able to get you an answer. 19 cents a gigabyte. That's cheap. All right, so this is my... Okay, so I want to end with my completely non-scientific observations from what I've seen with people that have to work with Hadoop. It always starts with Hadoop, that's nice, sounds kind of cool, but I don't have time or I don't have a need for it, and I get it. But then something happens in the business where you have to use Hadoop to get to the answer, right? You have to work with unstructured data, or that's where the data is that you need. So now you have to go use Hadoop. And then there's this moment where they're so excited. Oh my God, I can't believe how easy that was. I can't believe how fast it was. I can't believe that I didn't have to materialize this. There's something that gets them excited, and they get it. And then they get really, really frustrated with the user experience because it is not nearly as nice to work with Hadoop as it is the systems that you're accustomed to working with. There is not a nice GUI. And you guys are used to working with SQL Server Management Studio, a best-in-breed UI. And you're going back to basically command line utilities. It's not a good experience, especially for people that are very visual. And then ultimately, they get to this place where they understand how it fits in. It's not that Hadoop has replaced their analytics. It's not that it's transformed their job. It's that they understand that it is another tool in their analytical toolkit, and they understand when to use that tool. So that's my hype cycle. We've only got a couple minutes left. Real quick, please fill out the session evals. And I'm going to leave this up for some helpful tips and suggestions. And then if you guys have any questions, I will be very happy to answer them. Yes?
So Michelle, you've done a good job of explaining why people who are working with analytics should really be looking to do seriously. What do you think is the biggest obstacle? Is it the tooling? Is it the tool set, or is it something else?
What is the biggest obstacle to people adopting Hadoop? It is absolutely the tooling, right? The user experience. It's the fact that most of the people, most of the analysts that I work with, I mean, they can write code, but they definitely prefer click and drag. And you don't have any of that here. You have to learn the language. And there is no IntelliSense, there is no parser, there is nothing that gives you these really, these things that you've come to expect. And also, when you get the results back, it's on screen. There's no way for you to sort it or to filter it. There's no nice capabilities right into Hadoop, right? You have to ship the data elsewhere to your desktop to get that with Excel. Lastly, is that it's Linux-based. And most of the people that I've worked in my organization are Microsofties. And having to learn Linux and Linux commands has been difficult. But we have mitigated a lot of that by just simply having Windows to Linux equivalents and training and documentation. Good question. Another question. Can you download the presentation? Yes, it's actually on the past BA site. So if you go there and log in, then you can download a PDF of it. Was this helpful? Did you guys get what you wanted out of this? Does anybody think that you don't ever, in the future, will never need Hadoop? It's okay if you say yes, I promise. You know, if you're a data viz person, then yeah, you might never need Hadoop directly. Yes?
Another question. One of the things I'm wondering is why is Python seem to be so preferred with big data as opposed to C or something like that? You know, the answer to that.
Why is Python preferred? We prefer it for several reasons. One, it's a scripting language, so it gives us a lot of ability to automate. So a lot of our ETL frameworks are being built with Python. It's also kind of a master place to call all these sub-processes, right? So it's just a way to organize a data flow. So if I wanted to pull parameters from a config table, and then I wanted to run a pig script, and then I wanted to check on the results of the pig script to make sure that, even though everything processed, no data was written, things like that. I would control all that with the Python script. It would be the one place, and then I would call that from my job scheduler. The last reason is we're only talking about analyst here. I'm not talking about the data scientist or anybody else. Those guys love Python because there's so many libraries for them. So they can do a lot with the libraries that are available to them. Also Spark. We haven't even talked about Spark, but if you're looking at something like Spark or Storm, there's PySpark, which is the way to write Spark jobs. Other questions? Really? Okay. Well, thank you all so much. And if you have any questions, I'll be right outside the room. I'm happy to answer anything. And I know we talked a lot about analytics, but if you also have questions about ETL or the other stuff, I'd be happy to answer those questions too. Thanks, guys.